Okay, welcome everyone to this week's compiler architecture meeting. So today we have two new file into the compiler process. We should have some discussion around those. So the first is in an issue you then created in issue 2812, and I'll let her speak to that. Right.
So we're proposing to add Rebar opcodes because of two recent development items. One of them is for debugging purpose, we need to report all the field access to VM. And the other one is for pulseless GC, where whenever we load an address type object, address type field, we might need to call to VM to pick up the pointer if the object the object is already being moved. So both in both cases, the field load would have side effects. So we want to create new opcodes to represent both the load value and the side effects. So the current design is that we would have Rebar and Rebar I groups. Rebar is for load from static field, and Rebar I is for load from static field. And different field type would have different Rebar and Rebar I code. And the opcode would be similar to a call and will be hanging under treetop. So yeah, that's our initial thought.
Any discussion on that? Or?
Do you have some idea of exactly what is going to be done when that's evaluated? What does the evaluation look like?
The sequence generated in evaluator.
What would be generated?
In case of pulseless GC, it would be 2 extra instructions to do a bound check to check if the object is in the valid heap region, and if not, call out to the VM helper. And for the debugging purpose, for the other item, for debugger, we will call every time we do a field read, we would call out to VM helper to report the read, and then do the normal load and come back. So in both cases, it's like we might call a VM helper.
Okay. So it's possible that you would have to do both, like one or the other or both, right?
There are two different items.
It's one opcode, or is it?
Yeah, it's one. It's not. It's both of them use Rebar. And
what I'm asking is, there's a situation where you could be using pulseless GC and the debugger at the same time? Like, would you have to do both the bound check and the load and the notify the VM?
No, full speed debug I don't think will be turned on with pulseless GC together.
Why
That's
not?
True. Or
Your garbage collection mode shouldn't be dependent on debugging. At least today for Z, so we have read barriers implemented. So if we're not using an IL opcode, we do a reduction at cogen time, and there's no problem. Full speed debug with current Gavin John is fully fine.
And I guess.
I think in general it's useful for GC, just like we have write barriers for. I think there's Alex mentioned previously from the GC team on OpenG9 that there's other flavors of garbage collections which do require read barriers. It's something we don't explicitly dictate in the JIT today. Similarly to how we have card marking for write barriers. There's other GC policies that currently don't exist, at least in OpenG9, which could make use of read barriers if we have. I guess Paul's GC is just one of them.
Then I guess the answer is
short
yes.
answer is yes.
Yeah. Yes.
So there's a
I don't think the IL opcode itself should have any side effects. It should just behave like any other regular load as far as the optimizer cares.
But for field watch case, the debugger would want to know all the field read in the original code.
Okay, so
we cannot comment or.
So you cannot comment a read barrier node?
Yes.
That's going to be a problem.
Only if the debugger is running. So the behavior would change a little bit based on whether it has a side effect or not. What it sounds like is that you don't want it for positive GC, but you do want it for the debugger. So.
Yeah, so for positive GC, we were thinking only transform the nodes to Rebar at a lower tree so that normal optimization still kick in for the load.
That sounds unorthodox. Let's say, what's the point of having the IL if you're just going to reduce it to something at cogent time? You can reduce it to a call, for example, a special call read barrier. But the whole point of having the IL is so that the optimizer does care about it and can do stuff with it.
I guess we could make that argument for some of the other IL opcodes as well, right? Why do we have ones that get lowered in the, like for example, like multi-new array? We can probably lower that, turn that into a call.
That should be a call as well. I don't think we should introduce these IL that the whole compiler should care about, but really it's only the cogent. You're trying to represent an intrinsic at that point, like you're after optimizations. The need for that to be an IL.
Is that an argument for read barrier?
I would say that's an argument
Any
against.
optimizations on write barriers at all right now?
Like how does the optimizer treat write barriers today? Is it effectively a store?
If the right-hand side is a new, for example, trying to omit the right bar, it will mark the right bar. You don't need to do any bookkeeping in this case. I mean, there is a class of optimizations that happens in value propagation for right bars, to answer the question.
So to your question, are there any optimizations that could apply to read barriers of this kind? Like, for example, are there any opportunities for eliminating these read barriers by the optimizer if it can prove certain properties?
It would depend on if the debugger is running or not. If it sounds like if the debugger is running, you want to be conservative and not change anything, but the read barrier is for all this GC or some other less restrictive purpose, probably wants to do something.
And in the case of the debugger, where you need to report field accesses to the VM, does that also include writes? So if you write to that field, you also have to report that?
Yeah.
And would you use this to report that, or?
No, that's another topic. We are still considering whether we need to add a write barrier opcode for each type, or we can just use the store opcode. Because for write, the store would already have aliasing, so the aliasing wouldn't change for write or store opcode. But the rebar, aliasing would be different from a normal load.
For the behavior you want is you don't generate any different trees, but evaluation time, somebody's supposed to check if the field is being watched.
Yeah.
And then if so, do something.
Yeah. And that would also, there's also a problem with that because some of the opt that normally we can do for store cannot be done in this case. So that implies we might need to change some.
So why is that the case?
Yeah, what I don't understand.
Is it a Java thing? So you're watching fields that they can't be optimized?
Like, if a user, a Java developer, want to monitor the field access, they would want to know the access in the radio code.
Okay. And why would that matter? Like, what if the JIT optimizes store? Why would that? Whether you're running debugger or not.
In other compilers, if you want to debug optimized code, you have to live with the fact that things may disappear or change if they're optimized. So I'm just, the reason I asked is does Java let you do that, or does Java say that if something is being watched, it has to not be changed in any way, or because that would, if implementation and a lot of the problems you have don't it's easier.
From the last conversation with VM team, I was told that they would want to know the original read and write.
Then you can compile with no optimizations. I mean, because you can't specify an IL to behave differently based on text.
And the properties have to be the same, regardless of which mode you're in.
Mm-hmm.
The code that you generate conceivably could be different, although that needs discussion, but depending on the different modes. But the properties better be the same, right? Like it's always a trade-off or not, or have the same rep or not. Right? Those kinds of things have to be set. I think you are setting that somewhere saying it has to be a trade-off. We'll have a SIMREF on it.
Yes.
SIMREF will be aliased a certain way, disallowing commenting off the top code under any circumstances. Is that all correct so far? Or?
Yeah, those properties would disallow the commenting nodes.
So anyone else who wants to reuse this opcode better be willing to adhere to those constraints, right? So if you want a read bar that is a floating read bar, not a treetop one, if you want some other aliasing, or you wanted it to be comment, this is not the opcode for you. So that's another way of saying.
Mm-hmm.
Can the underlying load of the read barrier be common?
There will be no load.
So like in your case, the example, you've got an rebar I with an A load under it. Can that A load be common?
That A load can be common.
Because it's an auto, or because it's child?
Yeah, because it's an auto. It's not a field load.
So in here you have an arrow X read bar I that implies you can comment the results of the load as far as I'm reading. Is that what you intended, or?
That one is like for compressed ref. Then we will have a different treatop, but can reference to the same child, to the same rebar node.
If you allow commenting of load, doesn't that kind of defeat the purpose of the read barrier? Because what if somebody wants to use the read barrier to catch, to change the value before it's read? If you allow commenting, doesn't that allow the load to happen earlier and you're just reusing the value? And
yeah, I'm not sure. What's the case for disallowing commenting of loads that are read barriers?
You have to have.
Don't they have to be comment to use the result of the treetop?
Yeah, how would you?
They have to be comment downwards, but not.
Yes, it couldn't be comment up.
What do you mean comment upwards?
I mean, the load happens above, and the read barrier child is just the reference to previous load.
Okay, right. Okay, I understand. Yeah. To use the read barrier to catch the load before it happens. Right. Change it in the debugger or something. Yeah, I don't think the child of the read barrier should never be common.
It's just different than what we were.
Right. Wait, that didn't sound right to me. That last time.
I'm not sure we have one thing clear, whether the read bar, what is the read bar's child? I don't really think we've nailed that down in this meeting. I think the read bar is taking the place of the load.
Right.
So it's whatever the original load child was, that's what the child of this read bar node will be. In fact, the simref on the original load, or whatever the simref was on the original load I is probably what's going to be the simref on this read bar I. So, why we're restricting what can happen to time isn't then being read bar.
Okay, yeah, that's be common, no problem.
Well, unless it's another rebar in which case.
That special case aside.
Just out of curiosity, are there any other opcodes where we strictly disallow commenting in the same way?
Call.
Okay.
New.
Yeah.
New is another one. Because you have two new waves doesn't mean one allocation instead of two.
Right, okay.
But I think that's kind of the model that Yi is looking at, right?
Mm-hmm.
So your no commenting comment isn't quite no commenting, as the point was raised before.
It's always anchored to a treetop.
It's always anchored to a treetop. That's kind of like saying its ref count will be 2, but never more than 2. Never less than 2, never more than 2.
Consumer.
There's a treetop anchor. That's not a real consumer, though. There's a real consumer who consumes it.
Yeah.
Ref count becomes 2.
Yeah.
And then never increases beyond.
So why can't you comment it at that point, further down?
It's because of one of the use cases she talked about. Nothing in.
I read a value into a field and I stored it into a local. So I would need a rebar on the read of the field, but then I stored it into a local and then use the local 5 times. So I want to be forced to use the local because I'm not allowed to use the result.
That sounds like specification.
Yes, that's an indication that we want. So what's wrong with that? Yeah, that I read a value from the field. I did whatever I needed to handle that. I think what we wanted to prevent was 2 rebars being fused into one because they're reading the same simref.
So you could copy propagate.
And we don't think it's changed.
You could copy propagate, but not copy.
Right.
Fundamentally, she's in a mode where peak performance isn't at the top of her priority list.
At least for the debug
At least
case.
for the debug case.
You can just disable CSC in all your op strategy and move along. I mean, you can't try to optimize for debugging if you don't want the common read.
Then people come along and complain about how slow things are when I turn the debugger on. You can't go too far on that.
So is this intended to be used in Java's full-speed debug?
One of her 2 use cases is
So we have an existing use case that's in production today, which is all the GC on Z.
Yes.
And our reads behave exactly like every other read in the compiler, except that the very first read has to appear under a treetop anchor. That's it. That's the only restriction. So I don't understand why you would have to prevent commenting of the read barrier. Like our reads can have rep count 10 if you want, no problem. As long as the very first one appears under a treetop. And that ensures that our read barrier evaluator will generate the correct hardware read barrier sequence.
So I guess the question is, in the debug scenario, do you want JIT code to necessarily produce the same set of field read events as the interpreter would have generated?
Right. And if that's the case, I mean, we should disable optimizations rather than limit what the spec for the IL is.
That seems like a null on the performance versus observability spectrum, right? Like you could imagine people who would want to see every read and, screw the JIT. I don't want you to eliminate field reads. And you could imagine other people that are like, well, I just want to know when this thing got read and I don't care.
Sure, but isn't that an optimization rather than a specification?
Yeah, that's where I'm going with it, right? Like it's kind of you don't really know what.
If you want to see all the reads, disable local CSC. You will have them all. Everything will be a read barrier, no problem.
But isn't that giving back a lot of the performance that we were hoping to?
So you can turn off local CSC, and you're right. All the ordering would be exactly how it needs it to be. But that's not the only way you can achieve that, right? I mean, local CSC does local copy propagation as well as local commenting. As we just discussed, you could continue to do local copy propagation, just turn off commenting.
Sure, yeah. I'm just saying in general, it's an optimization that needs to be turned off if you want that desired effect. Not defining different specifications for the IL, which depends on.
Right. Why was there a different specification for the? Oh, so
because in one scenario you want to comment it, and the other one you don't. How do you define the IL?
The question is does the opcode require you to not comment or not copy propagate or whatever, right. Or is that just an option for?
Right. And I think that should be an option in whatever scenario you imagine your VM to work. Why can't a different VM, maybe a different VM, I don't know, your Python, if we don't need to report every single field watch, just the one that the JIT observes? In this case, sure, for those VMs, you would enable local CSC and go at it.
It doesn't seem so much a property of the opcode itself.
Right.
It's a property of what you're.
I think what you want to represent is the very first time you're reading it, you're accessing memory and you need to do something. After you've read it and it's in a register, use it however you want. That's totally fine. You're just moving a value around. You're not loading anything from memory.
In the Java debug case, how does somebody set a watch? What are they setting a watch on? Do they just say, I want to watch this field?
Yeah.
I want to be notified of all reads of this field.
Yeah, for certain fields.
Does that mean it becomes an OSR point as well?
Yeah. So we might start from normal full speed debug, and then if the field watch is turned on, we need to OSR recompile in the field watch mode. Yeah.
Can you get clarity on the specification if you missed one of these loads? Are you allowed to miss common load? How liberal is the specification in that regard?
GAG, that's not allowed. Yeah, but I didn't
It's
check.
an easy thing for the interpreter because they don't.
Yeah. They never eliminate anything.
Yeah. I don't know.
So that might be something to poke into.
Yeah.
Because it's kind of
They want to add
a lot of discussion is going on.
Why is it not allowed?
Mm-hmm.
Is it specified that somewhere? I don't know.
Yeah.
If the answer comes back that it's TBMTI, then that's not a good answer. Or that it's some Java-centric requirement, that's not a good enough answer for how this opcode should behave in OMR. It's an argument to say this opcode needs to support what OpenJ9 needs to do with this opcode, but it doesn't necessarily imply that the opcode has to do exactly that in its specification.
So
I mean, there's the argument that one has to adhere to what the interpreter does to be consistent. Different argument that one has to adhere to the spec, right? So if the spec gives us wiggle room that the interpreter doesn't take advantage of, it doesn't mean we shouldn't take advantage of it. So I think it's still worth digging into.
Well, still in the end, that's one interpreter and one specification. OMR is an OMR opcode. Right. There is no one interpreter or specification that determines what we do.
Yeah, it's also going to be an interesting description of this opcode, right? Yeah. What is it?
Yes, that's actually one of the things that I think is missing from this is like, what is the semantics?
So I'll
Just rebar.
I'll explain the significance
what does it do?
for Z.
What are its properties? Sorry,
For Z, the difficulty we had without having a read barrier opcode was that we were kind of mimicking it by anchoring the first load at cogent time. And the reason we had to do this was because a normal load can appear anywhere the first time. And in CodeGenerator, we have tons of sequences where we pattern match, some tree sequence, or we'd fold things into memory references, et cetera, stuff that you can't do on the instruction, which actually needs to generate the read barrier. So we have to know exactly the first time we see a load. We can't use like load and add because that flavor of instruction doesn't exist for a read barrier for our particular architecture. So they need to be anchored on a treetop so that we can recognize, okay, I need to generate just a very simple vanilla read barrier load. And then after that, you can comment it, do whatever you want with it. But as long as the very first one appears underneath a guarded load instruction for our architecture. And that was kind of the big difficulty.
So did you say that you accomplished that by doing a pass just before the code generator, like the end of optimization that goes by and finds the first load and anchors it?
Yeah. Some hacky, things like that.
After doing that transformation in the IL, did you still have other complexities in the evaluator, or that pass before you get into the code gen walks the IL, anchors the first load, currents of the load and retreater? Does that solve all the ugliness in the evaluator?
We had to disable a couple of other optimizations. We'd fold, for example, for, I don't know, if you have references, you want to shift the value, I fold and my index and base are the same, it's a multiplication by 2, so I just fold it into that. Those types of all those have to be disabled for read barriers. There's a whole bunch of cases in the code gen where we say, okay, are we generating read barriers? Is this one of these special ones? Don't do this op, shy away, which would be a lot easier if we had an actual read barrier opcode. Now, I don't know what other things you might be able to do on the optimizer side.
So it sounds like your requirement would be you want the opcode. You want opcodes to be anchored under a treetop.
And otherwise behave like any other load.
Like a load.
He doesn't care how many times you get the comment.
Yeah.
And shouldn't.
Yeah.
There's no reason why the GC should care. Read the value, that's when you do whatever you have to do associated with that load, and then use the value as many.
All we care about is we need to know the very first time we load this thing from memory. That's it.
Right.
And do something about it.
So even just within Java, we have the argument that this opcode needs to support a variety of use cases around this commenting versus propagation.
It's similar to a right barrier. I mean, right barriers more or less should behave like a normal store, except there appears on their treetop and you know to do something special with it, depending on your VM.
Yeah, so even after that discussion, it comes back to the same point, right? Are you allowed to comment this or not under debug? If the answer is yes, I think you can pretty much have it modulo something else that we haven't heard about yet, but pretty much have a consistent story across the debug and the positives. Be a treetop.
I think local CSE, there's an extension point, at least the SIMREF or something. We query something on the SIMREF to find out, can I comment this thing? Why can't under full speed debug or whatever, just create an extension point in OpenJ9 and just say, oh, if you're under full speed debug, no, you can't comment this load.
I think it's probably how she would have to implement it. Because I don't think there's just an IL
Like it shouldn't be baked into the IL
off local CSE.
and turned off at the OMR level. You should do it at the OpenJ9 level if that's what you need.
I guess that assumes that it's the SIMREF that knows the answer to the question.
Right.
Which, in this case,
it does, but maybe not in all cases. I mean, there's still I'm a user who wants to see the reads that actually happen, or I want to be able to see the event stream of reads that actually are done by my program. If the JIT optimizes 2 reads into 1, I don't care. I just want to see the ones that it actually does. That's not a SIMREF answer per se, although it could be configured that way. You could have a SIMREF that configures itself to give the answer, I guess. Yeah, I don't know.
even uncommon thing, want to see all the reads that actually happen.
I guess the question for me would be, is there, if it's going to be the SIMREF answering yay or nay, is there a case where only some SIMREFs would answer yes? And if that's true, then that's an argument for the SIMREF knowing.
Yeah. I mean, you can only watch.
If it's always one or the other, then that's an argument to me that maybe something else is the thing.
Right. In principle, I guess that's the point that we're imagining a local CC that decides based on the SIMREF could decide based on the node.
Right. Right.
And then it does have all the info and it can just say no thanks in this case. Yes.
Yep. I think we recently implemented something like this for some packed decimal commenting in OpenJ9, where we didn't want to do local CSD on a particular node with particular side effects, and that achieved exactly what we want.
Yeah, it's just a query and you just return no. That also eliminates some of the field reads as well. So we might need to change
that
logic.
Too has an extension point.
Yeah. Oh, that's yeah.
Yes, you can copy propagate if you.
Yeah. Yeah. So that's the only two of that's
eliminate.
Like, yeah. Any other offset I should be worried about?
Theory and local CSD. Come to mind immediately. I think the discussion was a good one that ended up in let's try to avoid the commenting through the optimizer rather than anything on the opcode. Opcode allows commenting or doesn't say anything about doesn't forbid commenting.
Yeah.
See if that works for you. Go back and think.
Okay. Yeah.
And I guess the other request was to perhaps document the actual semantics that you have in mind for these opcodes.
Mm-hmm.
Do we have I remember last time we met for IL specification, do we have any sort of template of how we want these things to look? This would be a perfect.
I was actually just thinking when she was, like 30 seconds ago, when she was talking about that we should actually come up with a template for these kinds of things in the future.
Yeah, no better time than now.
The information you need to be able to provide for us to have this kind of discussion. So I'll take that as a.
So if you do make this thing commonable, what are the implications on the rest of the optimizer, which probably queries for things like, oh, is this thing a load I?
Yeah.
Those places need to be switched to kind of acting on properties rather than actual IL opcodes. I would imagine so.
Going to be a lot of places that are specifically looking for a load
right.
opcode.
Yeah.
That will need to change to use it to represent the load.
Right.
If there's no opcode, a load I, do nothing, right? I use a rebar I that's going to match the code.
And I think we change that to it shouldn't be a load I or
yes.
a right bar. It should be a property of all loads of that specific type.
Or a set of properties that match the conditions that we use to check. Right? Is this a load of an address or something? Like, is this a load? Does it load an address? Is it an indirect load? Those kinds of properties.
We already have those kinds of properties.
Okay,
right?
that's great, but
yeah.
I bet there's still a lot of code that's specifically looking for an opcode value. And
I see.
And it
so
won't trip on these, and those should be changed to look at properties, not, as Philip says, to or it's a rebar I.
Yeah.
Because that'll be a much better way. Right. For looking at other things that are all loads and I have to just keep extending the forwards.
Yeah.
So you're also going to provide a version of these for each field type that we have right now. So BS, I,
L,
L, and V. And, well, yeah, so V.
I think it's 7 of them.
There's also a C somewhere. There's a C.
That one should. This is here. I have very much O and the alias to S.
Where does array access fit in here? You've got class static, you've got indirect object. What about an array load? Do you need a read barrier for that?
Well, possibly GC, yes.
Yeah. It is for both because you need to track what's being read.
Presumably.
Can you watch a load of an element of an array? Is that that's what's being asked, right? Element of an array?
It's called
but I wasn't actually concerned about that one. I was more concerned about the GC one, where you're loading an array, an object reference out of an array. That seems like a place where you might need a read barrier if you're doing.
Yeah.
It's not just a problem in enumerating it in the doc, because the opcodes used are the same, right? Whether you're doing an array.
But don't they have different numbers of children, or did we unified that by making two of them the same?
They look the same, whether it's a field or an array.
Mm-hmm.
It's an indirection of something. One case it's an object, the other case it's an array.
Effectively an AL add or an AI add under it for an array access, and just an object load under it for a field.
Yes.
So either case it's the address. That's okay.
So is that all that a GC read barrier is going to need in order to potentially update the pointer, the point of the read? I'm just worried that GC might want to have the owning object as well as the address of the element.
How do you guys deal with it currently with the load opcode?
We might not even know what the parent object is.
Okay. So the GC doesn't need to know, it just needs to know the address of the thing that's being updated.
Yeah. I mean, if it comes in through a parameter and it's an array element, you would never know.
Okay. Mm-hmm.
I need a specific instruction. Is there any reason why this would have to be evaluated in all of the code generators as opposed to some point before turning it into whatever needs to be done, call to some authority, and then a conventional load? Because the way we do things now is write barriers, go all the way to code generator, and everybody more or less does the same thing, and you repeat it 5 times.
Mm-hmm.
Is there any need to kind of go down that path?
I mean, we can generate a call node.
Before code generator, could you generate a call to init? That way you wouldn't need any, potentially you wouldn't need any code generator changes. It would just work across 3 or 4 or 5 of the code generators we have now.
For debugger case, we still need to do some check in both cases. Like in the debugger case, we need to check some bits to see if we do watch that field. Then we go to call VM helper to report it. We can do that in trees.
No, I was thinking before instruction function, turning it into simpler ops that code generators already support, that express what you want done without having to, that way you don't have to change any of the code generators.
For debugger case, I think that's all.
You have to read some bits and check if this field is being watched. Is that theoretically you could do that in trees? You could do it in both
trees or something.
Right. Yep. It's just the complexity. Is that going to have some? Is that going to be harder for some unfortunate technical reason, which is possible?
Might be
That's if it's just
for
a call,
his case, right?
But for what you want to do with how you want to reduce it is on your VM, right?
Yes.
So in this case, it would be Java or implementing that reduction. And it also might be different per architecture depending on how you want these read barriers to behave. I think we should be reducing anything at the OMR level, though.
Although I guess in principle you're already just using loads anyway. So the Rebar could just be lowered to whatever thing it is that the Z code generator is keying off of to generate that guarded load instruction anyway at this point.
Well, I think they're just generating loads, but then they check specifically if you've got a load right under a treetop.
Yeah, we pattern match a load.
I get it. And like my argument against his proposal, which was lowering because the code generators
yeah. I'd want to do that,
but you already sort of solved that problem in a certain way. It may not be the way we want to do it. Like you're relying on it.
So the biggest attraction for you from the point of view of the code gen is that by virtue of using a separate opcode, a new opcode, it breaks all existing pattern matches. That's one of the attractions. Why do you want to see the read bar?
Because I'm guaranteed that at a treetop level, I know it's the read barrier, and I know the thing under it is what I want. In this case, an object. I can generate an appropriate instruction for that without having to pattern match.
It's less fragile.
I have to consider everything under the sun, what shapes this thing can appear under any treetop.
I thought you saw that by anchoring into a treetop anyway. The first use will be under a treetop.
Right, and pattern matching everything under the sun in any way this thing could appear there. I'm trying to avoid that by having the IL specification guarantees that the very first goal.
Why do you need to pattern match anything to find the first occurrence of a zone? You walk the trees. You walk in tree order in visiting, using a visit count-like approach. The first time you visit a load is when you visit the load. No pattern matching. You visit it then, you pick it up, you anchor it under a treetop, you continue your walk. Why do you need to pattern match anything to anchor under a treetop?
I'll have to double check the code. It's more complicated than that.
The anchor in the
Just pulling on something that you had said earlier about perhaps in the very near future needing to use this for writes as well. From a symmetry perspective, I think it would be nice to actually have
the type of right.
Well, it's explicit, it's read and write. Like, is there some kind of a generic access barrier that we could come up with instead? Think of it.
Where would that go? Where would that go? Underneath
generic.
So instead of, let's say, having 9 times 2, so 18 read barriers, and then another 18 write barriers, we can shrink that down to 18 access barriers of some kind. Yes.
That's how the right barrier behaves today. The type of the right barrier is the type of the first child.
And the right barrier has different semantics depending on the DC mode. Some of them want for the right, some of them want after the right.
Yeah. I guess I'm just trying to, if we can, inject some symmetry into this. Because one of the other options you were saying is that you don't even need to have an explicit barrier for stores. Maybe it's just...
There's already a precedent here, right? We already have load opcodes and store opcodes, which are symmetric in some sense, but they're only differences.
Then that would
be a flag on those nodes, which indicates that they're a read bar or a
but that would argue that you'd want to have right barrier codes, not just fold it into the store. Like I think what he was saying. There's one possibility of implementing that. If you want to expose symmetry, then that's fine, I guess.
I think we had trouble defining what the opcode does, even without that generalization.
That's right. What?
So the original read bar opcode, what does it do? Is one of the questions that's still outstanding. So, well, but exasperating to
approved.
Plus, it sounds like a slippery slope where you can then start making the same argument. Maybe that's what Mark was saying about if you don't need a read bar and a write bar, do you need a load and a store? I mean, why not just have one thing that represents load and store?
But the difference
I'm not proposing that.
If the direction you want to go,
decidedly against it.
The children are different.
Sorry?
Well, you need an extra child for the list.
So I'm just saying that's a deep question that probably will end in the answer, yes, we do want to distinguish between loads and stores, and yes, we do want to distinguish between read bars and write bars.
Okay.
But it's a valid question to ask in an effort to keep our opcode numbers down. We should do the thought exercise. But sure hope it doesn't end where I outlined.
200 opcodes for factors.
With one instructor.
When I effectively
an opcode that does add or
We dramatically simplified our.
well, Mark, we keep talking about this do what I want service. Maybe we just do what I want opcode.
Right.
And then I think as well, I guess I mean even as part of how we want to how do we want people to request new IL opcodes in the future? I think part of the thing you need to think about is testing, especially in the context of OMR, and how we're going to test the new opcodes. So we need to have a way of whatever semantics come up with for read barrier, we can actually test with a drill test or a compiler test, and make sure that it does what we want it to do.
yeah, at least properties like, is it actually under a trade-off? Has it swung down?
Oh yeah, validation is another one, yeah, that's right.
The very properties you're so anxious to see preserved, to have a tree verification process. Takes care of that.
Mm-hmm.
All right. Any more discussion on that one?
What's the default implementation? Do we just map the right barriers to loads? Or read barriers to loads?
It would.
What is the default implement evaluator in OMR for read barriers?
Sorry, and what sounded reasonable?
Just to map it to its original load. And then projects would provide their own evaluator, override the evaluator, like delegate them. Which we need
And do we even want to, do we supply a right barrier evaluator in OMR?
Good question.
I don't know.
Never looked.
I'm sure there's a big
We haven't got there yet.
I think that's one of the things that gets swapped in the table, isn't it? The evaluator table. We need a better story for that.
No.
Okay. And then OpenGen would write in the new evaluator during code implementation.
OMR.
Yeah, I think
It's probably okay. Somebody ends up writing a test for this, I imagine they would override that to do what they want, call a function in their test framework, so they can use that to validate it's doing what it wants. Anybody who wants to use it for actual purposes will do the same, and everything would just work out.
I guess that also begs the question, how would you generate these in the first place? So is that a front-end type thing, or is that a configuration in OMR saying, I want to generate read barriers?
it's up to your.
Shouldn't most of them be created with factory methods on Node? Isn't there like create load avoid somebody manufacturing a load out of thin air and not realizing they had to make it into a rebar.
Right, that's what I mean.
That's subtle, though. Like what do we use create load for like you only want to do this for heat objects, right? So and static. So if we access something off of a VM thread or some other kind of data.
So it has to be smarter than just the...
Right. And then you can still work around that. So you can create your own node without using create load, right?
Yes, you can.
It's a tougher thing to violate.
Yeah.
It's like,
Is that how you were thinking of doing this? Having, like not explicitly going and creating a rebar, but letting the existing framework say, oh, I know your load of the heap, so I need to get you into something different back?
No, it's not. What I'm thinking is not that smart. It's just in ILGen, we would know if we are accessing a field. Then query the front end to
You can generate it for all field access.
Yeah.
So then we shouldn't implement the opcode in OMR.
Sort of, your conclusion was we shouldn't have the opcode in OMR.
We shouldn't implement the evaluator. There should be no default evaluator for a read barrier.
Mm-hmm.
If there's no way to generate it in OMR, there shouldn't be a default implementation.
Okay.
Is it going to
So
be
you're
used
going to
in
make,
the future?
when I write a read barrier just build their service, you're going to make me implement the evaluator for it too at that point?
You can map it to the OMR's load evaluator, no problem.
What's the downside of having an evaluator in? I guess we don't know what it does. So.
Right. It's kind of hard because, I don't know, some VM, for example, Java, might only want read barriers on heap objects. I don't know, if I'm implementing GCC, I might want to run every read. Doesn't matter if it's heap or not. But if I want field watch on a stack allocated object.
Shouldn't like a pauseless GC implementation then sync into OMR at that point and become part of the rebar? Like, if some other OMR consumer wants to use the pauseless GC technology and the evaluators exist in OMR, which I don't know if they do right now, but shouldn't that be an option available? Which would imply we'd want evaluators in OMR for rebar. It won't take me very long to write a rebar.
If you do that in zip builder, don't you also have to provide other things to allow somebody to get a watch actually working?
Yeah.
A watch, sure.
Or even they would even have to tell you, what do I call?
Yeah, we got it.
Seems like a very front-end type thing.
I mean, but this goes back to the what does this opcode do?
Yeah.
Question, right?
Yeah, if all you want to be able to do is some kind of platform-specific function when you see one of these write barriers for the first time, whatever that function happens to be, even in OMR, we could map that to something that that does something that we could use to test, right? I don't know, like print out the value or whatever it is you're reading. I don't know.
I mean, presumably the lowest bar here is that the read bar is a load, right? It does the same thing as the load, because either you're not in the GC thing that you want, or you're not watching fields or whatever. It has to behave like a load, so that seems like a good default to me, and we should provide it in OMR. Then we can generate tests, which can run the IL validator, which validates that the read bar nodes are being handled appropriately throughout the optimizer at OMR, and that they can functionally, they do actually load a value, right? Which is what they're supposed to do at a minimum, right? That seems to me a better default than unimplemented.
Yep. as long as we specify the feed barrier to be a strict subset of what the properties of a load are.
True.
Which is TBD.
Yeah.
We still need a specification.
Yeah, exactly. Yeah.
Okay. Any more discussion on?
So that's what are the next steps?
So I guess document what this thing does. I think you were going to look into whether or not some of the constraints could be relaxed. I mean, I guess this is going to get into the semantics of what this does, right? So you need to kind of factor that into that. And I need to come up with sort of a template for what information needs to be provided for proposing a new IL opcode, and I think that hopefully you could follow some of that. Is this like super urgent for you? Like you have to get this? I'm just wondering what your expectation is for.
The VM team asked about it every think-up meeting.
Okay, I'm just thinking if you need something like by Friday, I mean, that's one thing, but if it's
not like that.
Okay. So testing is another consideration as well. So what we're going to add this to OMR. So think about how we're going to test this for the various data types, and static and or direct and indirect as well.
I think modifying all the locations in the optimizer that care about the specific IL load needs to be changed to act on properties instead.
All right. Okay. So that took longer than I had expected it would take.
Discussion.
Yeah. So the other one is I'm really hoping we can get through it in 20 minutes, but so it is a proposal to add IL opcodes for. Actually, I'm going to time box it at 20 minutes anyway, so it doesn't. We can't conclude the discussion then. We have to carry it on some other time. But the proposal is, let's bring it up here, and I'm going to speak on behalf of Shivam, who's, so one of the things that he's working on at the moment is adding support for FMAs into OMR. This isn't necessarily for languages, well, it's not for languages like Java. It's for but there are uses of this in Java. And one of the things that you like to do is to add new scalar FMA opcodes to OMR. And the reason I called out scalar is because there already are vector FMA IL opcodes in OMR, of all things, which...
with the easy stuff.
Yes. Which I don't think are actually used or in any way, shape, or form, but they're part of our API. So so anyways, the proposal is to add these 8 new IL opcodes. Where they could potentially be generated is actually during simplification. So we can actually recognize or doing some kind of an idiom recognition pattern where it can discover these sorts of operations and then turn them into an opcode like this. It could also do further simplification of these opcodes as well and do value propagation or what have you, folding or something as well. The semantics of these probably need to get specified a little bit more carefully. I think he's got the arithmetic operation here, but we may need to go a little bit deeper in terms of specifying what exactly it is that the semantics are going to be. We had a discussion about a month ago on floating point semantics in OMR, and really the answer that came out of that discussion was that we need to have a means, and we don't have this yet, a means to actually delegate to some kind of a language environment to ask it what the proper floating point semantics are in that environment. We have the arith-env class at the moment, but that may give surprising answers in some contexts that we need to. OMR shouldn't be. Yeah, I'm not sure what I'm trying to say here. OMR may give surprising answers that a particular language runtime may not want to give. So, why did I say that? Well, to define the actual semantics of these opcodes, like for folding and that kind of thing, I think that we need to be able to provide some non-surprising means of folding these kinds of operations. So, yeah, so the idea here then is to introduce these IL opcodes, have them generated either by a language front end, if it can, or actually generated within the optimizer. The backends would then go and map these ideally to hardware instructions. Even if they're not necessarily supported, they could be implemented using instructions as well, like the individual instructions. I'm not sure why you would do that, but that's a possibility for breaking these apart. And I would imagine he's going to be creating some test cases as well to demonstrate that. But anyways, a lot of that has to actually get documented here. So, any thoughts, opinions on this?
Can we expand the names?
Expand what they mean?
No, just one of the operations gets, well, either the add or the sub gets written out in full, but the multiply and the neg don't, so it just makes them hard to read for me. I don't know. I would prefer fmul add instead of mad, fmul sub or something like that.
Okay.
Fmul add. I don't think the saving the 2 to 4 characters in the opcode name is.
Okay. And that may have been just like copied from the vector versions.
Probably.
We could do the same.
Yes, were added without review from anyone. So.
I think those just were inherited from the active open sourcing. So,
yep.
Okay. All right. Suggestion.
I'm just looking quickly at the pull request that was open for these. In the properties table for these opcodes, it says that the opcodes have 3 children of unspecified type. Is this correct, or
For the scalar ones, they should be float or double based on the.
All right, so that will be something to.
I believe that was probably copied from the vector one.
Okay.
Yeah, it should be float or double. Data type is float. Okay. Any other thoughts?
Was there a clear use case or motivation for this, or is this just based on what you said a minute ago about the simplifier finding patterns and turning them into this?
So
what can happen after that that's good?
What can happen after the simplifier that's good?
What can happen after these things are created that can't happen if they were left alone and separate multiplication?
Well, I guess there is motivation for finding them in a common place, right? As opposed to having each backend recognize the pattern and turn them into an actual, like a single instruction. He actually does have, I think maybe there's even another pull request that's kind of a work in progress that may or may not see the light of day, where the pattern actually is recognized in the backend. And the comments that he received on that were, we should actually have this recognized happen in the simplifier, but it could happen. But there are some benefits, perhaps, to your from folding and value propagation, whatever, for recognizing them earlier.
Does Power have instructions for these operations?
Yeah.
So this was targeted towards x86, but no reason why it can't be extended.
Right. We have, if you look at the implementation that we have on FMAs, it's got a very mixed history in the code base. There seems to be three distinct eras in which FMAs were introduced. There is some very early code that was introduced to try to recognize some extreme corner cases for Java. I think that was done on Z for sure, and I think Power as well. And then I think later on there was another mapping of FMA instructions to, or FMA opcodes. I think this is where the vector ones came in. Under control of an option. I think that's only done on Z if it's float math option, which doesn't do anything at the moment, but we still have code guarded with it. And then there's this attempt here. So we do want to clean this up to have one sort of consistent way of doing it. There's these opcodes, but then there's another sort of thing that he's working on as well for Java 9, where there actually is a math.fma method that was introduced in the math class, in the strict math class, where Java allows you to do floating point FMA arithmetic, basically. And he's mapping that method to instructions in the backends that support it. So, but that won't use this. These are, like for OMR only, or non-Java languages only.
So would the first step be conditionally generate these as part of some simplification, depending on some code-generated query?
Yep. That and whether or not the language environment supports fuse multiply.
Is the code-gen a point-in-time statement? Is it just that we haven't implemented the other code-gens, or not all code-gens might support this?
The code-gen question would be whether or not there's actually support there for it, whether or not potentially you actually want this, you actually want to do this. Like, for example, you could have an option that says, I don't want to do this. And whether or not the target, the target processor that you're generating code for actually supports these instructions.
There is
missing right now, right?
Sorry?
Those queries right now are missing from the pull request that's here. It's just providing support.
Yes.
There is a complication on Power where an FMA doesn't behave the same as multiply and an add for full use specifically. Because I don't remember the exact details, but it was something along the lines of
It's the internal precision of it. That's why you can't use it for Java.
Yeah, and NAND and signals and whatever. So that wrinkle would have to, the fact that it has slightly different behavior.
It kind of comes out in the question that you'd ask the language front end. I'm going to do, but it doesn't necessarily reflect. I guess you might need a further refinement of the question may not be as so simple as do you support FMAs. It might be do you support FMAs with these kind of semantics. The subtleties of that haven't thought through how to refine those questions. Drupals. Well, if you can pull out the differences between, let's say, a Power FMA and an x86 FMA, and if there's some subtleties there that
there are a ton of stuff. So another one is Fmax and Fmin don't behave the same way as if X less than Y return X else Y. On Power, it behaves. The IEEE definition of min and max, there are differences, so we don't generate F cell, for example. So,
okay. Well, I mean, those kinds of questions we need to probably surface in that arithmetic layer, which is pretty thin right now.
So in the pull request right now, it looks like there's nothing that would actually generate in any one of these instructions, right? There's a simplifier handler for
Right.
these types of operations if some of the operands are constant, but something would have to actually
generate
specifically
tests.
these opcodes.
I think it would be tests, like trail tests or something like that, that would drive this. I think somebody smiled today. Okay, so I guess next steps on this one is to, again, similar to the previous one, is to provide more details on the semantics of these and sort of the testing strategy for this. It's also got that extra wrinkle about folding these things that and the floating point semantics that we don't have a solution for yet. Okay. Anything else on this? Okay. All right. Thanks, everyone. We'll have another architecture meeting in 2 weeks, and I'll get the agenda up there so that people can add proposed ideas. I already have one thing in mind. Already somebody lined up for that, which might take the entire time. But feel free to add if you think you want to add something to that. Thanks, everyone.